Hello, my name is Robert Smith. I'm with New River Community College's Academic Assistants, and today we are discussing molar mass. I have 3 examples for us today, and we're going to go through each one systematically. The first one says, how many moles of hydrogen are there in 6.45 grams? So, to determine this, we simply need to look at the molar mass of hydrogen and then relate that through dimensional analysis to the mass given. In order to determine the molar mass of hydrogen, you're going to have to look at your periodic table. When you do, you will find that the mass of hydrogen is given as 1.008 grams. Well, that's a mass of hydrogen when there is 1 mole of hydrogen being assessed and measured. So this actually means 1.008 grams per mole. So now that we know that the mass of hydrogen, this would be the mass of hydrogen, the molar mass of hydrogen, is 1.008 grams per mole. And then it's very simple dimensional analysis to find out how many moles of hydrogen are in 6.45 grams. All you have to do is take your given, you always start with your given, 6.45 grams. And then we're going to want to multiply it by the molar mass of hydrogen. But we're going to want to rearrange the molar mass so that we can cancel out the grams and only be left with moles. The easiest way of doing that is to look at 1.008 grams per mole as being the same as saying for every 1 mole there are 1.008 grams. It's the same thing. And then you'll note that grams and grams cancel each other off, and you'll be left with moles, which is exactly what we want. And when you do the calculation, you basically divide 6.45 by 1.008, and you're left with 6.40 moles. And that's the answer. Note that there are 3 significant figures given, and there are 4 significant figures in the molar mass. So we want to make sure that we use the least number when we're multiplying through. And that's why we have 3 in our final answer, just 6.40. Next example. How many grams of copper are there in 0.357 moles of copper? Again, we're going to want to find the molar mass of copper. And you do that by looking at your periodic table. Once you've looked there, you'll find that the mass of copper, denoted M sub Cu, is 63.55 grams per mole. Always include your units. And just like the previous example, we're going to start with the given, which is 0.357 moles. Note that there are 3 significant figures in the given and 4 significant figures in the molar mass. So our end result will have 3 significant figures because, again, we're multiplying. And whenever you multiply or divide, you're going to use the least number of significant figures as the guideline for your answer. So, again, we're going to want to multiply this one by the molar mass, but instead of our previous example where the moles were on top and the grams were on bottom, we're going to flip it and say that 63.55 grams per mole is the same as saying 63.55 grams per every 1 mole. Moles and moles cancel each other out, and you'll be left with grams as your unit. And when you do the multiplication, you'll find that the answer is 22.7 grams. Again, keeping with three significant figures. The last example I want to go over is involving Avogadro's number. So, the question asks, how many atoms are there in 16.4 grams of phosphorus? That seems a little intimidating at first, but don't worry, we'll work through it. So the mass of phosphorus, the molar mass of phosphorus, as given by the periodic table, is 30.97 grams per mole. That's a safe bet that you're going to need that, because in order to determine just about anything, you'll need the moles of it, because the moles allow for direct relations. So next we're going to want to create a dimensional analysis that can get us to atoms. And you'll see why we needed that molar mass here in just a second. So we'll start with our given, 16.4 grams of phosphorus. We're going to multiply it by our molar mass to get the number of moles. So, or rather, we're going to divide it by the molar mass. But I always use multiplication. It's just easier to visualize as you're crossing out your various units. So for every 1 mole of phosphorus, we have 30.97 grams of phosphorus. Grams and grams cancel each other out. And we're left with moles. But we don't want moles, we want atoms. Well, think about Avogadro's number. Avogadro's number is 6.022 times 10 to the 23rd. And you might be thinking, well, that's just a number, but that actually means it's that many atoms per mole. So there are 6.022 times 10 to the 23rd atoms per mole. So we write that out. 6.022 times 10 to the 23rd atoms per every 1 mole. And look at that, moles and moles cancel each other out. And we're left with atoms, which is exactly what we wanted. So 16.4 divided by 39.7, and then multiply that whole mess to 6.022 times 10 to the 23rd will get you 3.19 times 10 to the 23rd atoms. And that's our answer. Note that we kept it to 3 significant figures while using scientific notation, which is exactly what we needed to do, because 3 significant figures were our least number of significant figures when multiplying.